Thank you, James. It's been a hero's journey for each one of us in the last 12 months, navigating through this pandemic. Fractal's hero's journey began on February 27th, 2020. We were all in a town hall in London. Just the day before that, Donald Trump and had visited India and had, famously, said that COVID is not going to be there. And the next very day, we were in London for a town hall, Fractal Global Town Hall. And along with that, we had an event called AI.LCY, which was our London AI event. While that event was going on, we suddenly got the news that COVID was beginning to spread. There were a number of cases in London, and then our journey started. And let me share from then onwards. I need to be able to share my screen. Can you please enable that? Okay, thank you. From then onwards, we decided to put some very strict measures in place. We stopped all travel. We all got back to our respective locations, US, UK, Australia, India, and so on. And then on March 1st, I decided to write to a few authorities, government authorities across India, offering our help and support for what seemed like a crisis about to unfold. On that day, there were 3 cases in India all together. I got no response, but on March 21st, I got a call from the municipal commissioner of Mumbai, who said we needed help. And then right after that, within a couple of hours of his calling, we were on this conference call. It was a WebEx conference call with Mumbai Police, the Municipal Corporation of Mumbai, which is called BMC. And we got AWS roped in and a few others. And we were on to a journey in trying to help the city of Mumbai and later on governments of Karnataka and Telangana in navigating the COVID crisis. As we went through that, one of the things that struck me the most was that the key problem kept changing. At the very beginning, it was about tracing arrivals. It was about who is visiting India, and Mumbai and Delhi are the two biggest places where most people sort of enter into India. How they were just trace their arrivals and make sure that we can track their activity. Are they buying any prescription medication? Are they, do they show any symptoms? Who are they in touch with? Could we get that kind of information? And as you know, Mumbai Police has these kinds of information, and we were beginning to look at that. That was the first week of this crisis. In the second week, it was already different because we had started noticing that community transmission was taking place across the city of Mumbai. So as soon as cases started rising, it was about containing hotspots. It was about Mumbai is divided into 6 zones and 24 wards. And the idea was, can we find out at a zone level, at a ward level, which are the wards and zones that will actually likely to be upcoming hotspots? So we were building mathematical models to see which would be the problem areas within Mumbai. We quickly realized that we could use epidemiology models and build better models there. And we started using some machine learning on top of the structural models, and we started looking at hotspots and recommending to the municipal commissioner and his team about where to create containment zones within the city. But after a couple of weeks, this problem had gotten worse. And then it was about predicting the spread at a much larger level and plan healthcare capacity. How many PPEs required? How many hospital beds are required? How many intensive care units are required? How many healthcare workers do we need? And these also kept changing, but the idea was capacity of the healthcare system to be able to manage the spread and to manage the number of hospitalizations and to prevent as many deaths as possible. And this went on, and it was a really difficult time. I mean, I remember our teams working 18 to 20 hours a day. We had a 50-member team at Fractal working, this is all pro bono, working with the government of Mumbai, then the state government of Karnataka, and the state government of Telangana, 2 states and a city. Mumbai, a city of 20 million people, right? And Mumbai was just like New York. in the sense that the number of Mumbai was probably 2 or 3 days behind New York in terms of the number of cases. And it soon became a really, really difficult problem to solve. And we were working 18 to 20-hour days, thinking that even if we take a 1-minute break, maybe somebody will die because of that. It was that challenging. But we kept on working. And then the problem became something else. It was about, and this was specifically in Karnataka, where the question was, can you find out, as soon as somebody finds out they're COVID positive, can we get them to a hospital or a quarantine facility within 2 hours? So it was about designing the whole process of from COVID positive to admission or to containment within 2 hours. That was that. And then I remember this very vividly, remember the day we actually presented all our findings. We had data on 6,000 people who had died in Mumbai, and this is sometime in June or July. And by then 6,000 people had already died within the city of Mumbai. We had the data and we could use the data to understand what are the comorbidities and so on. So we started looking at the comorbidity data, and we saw that hypertension, diabetes, tuberculosis, these are all very strong comorbidities which increase the chances of mortality significantly. And we delivered this presentation to the panel of 10 doctors in Mumbai, who listened to us very carefully and then instantly made a whole host of decisions which also prevented future deaths from happening. Meanwhile, we were also working with Cure.ai, which is our healthcare AI business. What we did was we repurposed the tuberculosis algorithm to detect COVID. And immediately we saw that there were a huge need for that in Italy, in London, in UK, in NHS, in the US, in Mexico, Pakistan, a whole host of countries around the world. Now they were beginning to use the COVID detection using an X-ray. And this meant that we could not only detect COVID, but also make some very important decisions like, can we discharge a patient? In Mumbai, for example, hospitals were already full. So Cure.ai's algorithm was used to see whose X-rays are cleaner, therefore could be discharged safely, as opposed to the others who should be kept, so that we could free up hospital beds. So we kept on working and improving and sort of solving the problem. And the important thing here is, and then the last thing was about unlocking safely. Once July and August came around, it was about unlocking the country, and we had to decide on which industries to unlock by looking at the working population, where they were going from which location to which location, and therefore by unlocking which parts of the city or by which parts of which kinds of industries, what would be the impact on the number of cases. In all of this was all about working backwards from the decision. We knew the decision that the Mumbai team or the Karnataka team or the Telangana team had to make, and we were working backwards and telling ourselves, what can we do to improve this quality of this decision, speed of this decision? And this is the first thing for me, that in general, we have this mindset of data forwards thinking. Okay, I have all this data, what should I do with it? What kind of insights do you get out of that? Instead, this is all about working backwards from a decision. And this is the first big insight for me. And in fact, I would say that if you are to deliver results at scale, I suggest to you that there is a formula for delivering results at scale. And as a Fractal client and a Fractal client advisory board member, you know that we have been speaking about this for a long time. It is about AI, smart algorithms. It's about engineering, and it's about design. And the results formula is essentially AI multiplied by engineering squared, multiplied by design squared. And I'll tell you why we think it's engineering squared and design squared. AI, smart algorithms. Yes, we know that already. It is the intelligence in the system. Engineering, because not only does it involve seamlessly connecting data pipelines so that we can build the right models, but it's also about automating those decisions in real time and scaling them at internet scale. And we could see that in the case of Mumbai, because yes, we had some very smart algorithms on AI. We were using a concept called RT, which was real-time spread indicator. The idea was that R, which is the rate of spread of the disease, was itself changing every day based on the various kinds of practices, masks and social distancing and other kinds of policies that were there in place. So we were using a real-time RT and building a machine learning models on top of that. On engineering, we started doing, we had to connect all the data pipelines and deliver results in literally 3 days. In fact, we were asked to deliver the results next day, and knowing how difficult and dirty the data sets were and how scattered they were. And this is a government, we are talking about government data sets. There's nothing in place. I thought it will take us weeks, if not months, to deliver. But we could start delivering results to them in 3 days because of cloud computing and other kinds of infrastructure that was there, we could really quickly, in a very flexible way, start delivering outputs that they could use within 3 days. And from a design standpoint, it was always the problem kept changing, and we had to drive those decisions. We had to not only produce the data and the results, but really work with the decision makers, explain to them, and help them drive greater policy. And because engineering has these two dimensions, I think it's far more important. AI, great, but engineering, super critical, and design, even more critical. That's why I think driving results through AI is about AI times engineering squared times design squared. This is the first formula I want to present today, and I have two more formulas for this talk today. And I'll explain what this means. Number one, it's results is AI into engineering squared into design squared. But if it's error, how do you reduce? Once you're solving a problem, you know what the problem is. How do you reduce error? How do you improve accuracy? I submit to you that it's data times compute times technique. And a third formula called organizational effectiveness. How do you drive greater effectiveness as an organization? It's talent times culture times governance. And I'm going to walk you through what this means in the next few minutes. Let's go into error. Now, once we know what the problem we are solving, it is all about reducing the error rate. And we have seen tremendous progress in the world of AI in the last few years in reducing the error. And there are three key dimensions here. One is data. If you can increase the size and quality of data that you're using, certainly error can come down. If you can increase compute or improve the quality of the technique, you can also reduce error. And now what we're seeing is that it's a multiplicative effect of these three. And in fact, what you're beginning to see is that once you increase compute and data and techniques, the error rates just plummet. And nowadays there's a trade-off. In fact, in some cases, for example, Google has shown that if data sizes are small, for example, in natural language translation for the languages that are not very well spoken, for those, if you just increase the compute, you can get a similar accuracy. So it has become a multiplicative thing, compute, data, and technique. Now let's go a little bit into data. First thing here is about more sensors. And we have seen that the moment we increase the number of things that we're measuring, we can do in industrial examples, for example, we have seen predictive maintenance saving millions and hundreds of millions of dollars if we add more sensors and start measuring. But it's not just about manufacturing. In every industry, you can see that by sensorization, you can actually collect more data and improve techniques. We've also seen alternate data. For example, in Theremin, which is our AI-driven investing business, we have seen that if you actually start looking at data like parking lot data to see the earnings performance of a retailer, or you look at the earnings conference call data and look at the voice tonality of the CEO and the CFO, or if you look at satellite pictures to understand crop yields, you can actually get this alternate data which gives you a new signal that improves the overall quality of decision making and overall reducing overall error rate. The third and fourth dimensions here is about synthetic data and experimentation. Nowadays, you're seeing a rise of synthetic data. And one of the things we have noticed is you can use synthetic data to build the models, but I always recommend that you use actual data to validate the results. And finally, experimentation. The more you explore, the more you have budgets to explore, you can create new data because the feedback that you get from the experimentation is actually new data. And there you can improve the quality of the models. Coming to compute, you're seeing a rise of cloud computing. And one of the reasons we could actually deliver to the Mumbai and the Karnataka and the Telangana governments is because we could set up a very flexible system in literally 24 hours. All of this could be set up in 24 hours. We are working in a very hyper agile mode, but still we could do this in 24 hours and start producing really important outputs in 3 days. It's because of the rise of cloud computing. And we are living in this very important era of computing where the compute loads have just gone through the roof. It's exponentially increased in the last 2 to 3 years, especially with higher parameterization of models and so on. But compute has become cheaper and compute has become abundant, and everybody is raising the level of compute in their own organizations. We've also seen that while compute is going up, we also have these cases for edge computing or fog computing. And how do you do that? I mean, for example, in Mumbai, we were trying to understand using cameras and drone cameras. We were trying to assess where is social distancing compliance being met or not met. This is one of the solutions that we built for Mumbai police as well. And one more example is in Africa, where we're deploying TB solutions. and we realized that there's simply no internet connection. So we created Cure in a box. So everything on this box, there's GPUs, all the decisions. You just plug this box in, and you can have an X-ray AI algorithm detecting tuberculosis and so on. So this is another example of edge computing. And the last point here is about about quantum computing. You've seen Google declaring quantum supremacy in 2019. This is very early days, but in the next few years, quantum computing promises to be something extraordinary, because it can really reduce the complexity and the order of computation of very complex problems from exponential time to polynomial time. So this promises to be an extremely important area of technology to invest in. So this is about compute, but the last point I want to mention here is custom AI hardware. You're seeing rise of ARM and other kinds of methodologies, tensor processing units, and so on, which is also increasing the compute. From a technique standpoint, we had used structural models. We used the basic spread understanding of the disease, and because of which our models gave through some results which are extraordinary. I mean, they were bizarre, because when we saw the numbers, I couldn't believe that India would have those many cases. But India ended up getting 11 million cases, and our models were actually right, because not only were we using ML, we were using the structural understanding of the disease spread, and that really improved. What we are seeing again and again is that if you have a causal understanding or a structural understanding, there is a lot of reason to believe that you can improve the overall performance and reduce error rates. And there are better techniques too. And deep learning, while it is extremely popular right now, it's not clear that deep learning is going to be the future, right? There are so many new competitors for deep learning. And eventually, we know that better techniques are going to come through. And you're seeing rise of transformers as a technique, or GANs, or other kinds of new learning, deep reinforcement learning, and so on, which are also promising to be the panacea for better techniques and for stronger AI. And the last point here is about federated. There's a privacy, the continuous learning of models is another area which is growing a lot. For example, federated learning, where it is privacy preserving, but each device in itself learns a little bit, sends the update in a privacy preserving way. And you can see that kind of a technology is also going to become more and more useful. And any continuous learning system also will actually reduce the error. So that's about reducing the error. And now let's talk about how to improve organizational effectiveness using AI. And if you are setting up a team, if you're setting as one of the senior most leaders of your organization, you're thinking of how do I build the organizational effectiveness around AI, I would submit to you that it's about talent, culture, and governance. Talent, game-changing talent today is 5 to 10 times as valuable as regular talent. Take an example of sports, right? We know here that game-changing talent is paid 5 times, sometimes 10 times the average player. But unfortunately, in our organizations, we don't do that. And that's one of the reasons why you're seeing that talent is going away to organizations that recognize this and pay more. So that's one, game-changing talent. At Fractal, we have been trying to raise the bar for talent. Today, it's about 0.29% of people who apply to Fractal get admitted. In the last 12 months, this has been the number of our statistics, but we still have to keep raising the bar for talent. And once you have the talent, you have to have talent which can actually be objective, which can really see for what is happening and be neutral, dispassionate, and have the rigor of a scientist. Because eventually you can get great results in test conditions, but when you actually put them in practice, they have to work. And for that, you need the rigor of a scientist and the sort of the dispassionate approach of a scientist. And I couldn't find any better way to describe this than what John Maynard Keynes said about economists a few years ago. Now, we've talked about talent. Here, the additional dimensions is about having an interdisciplinary team. Can we really bring in different kinds of people who are differently wired? We have a talent, for example, Fractal has a career grid, which has different kinds of talent, how they can come together. But this is necessary, but not sufficient. We have people from different backgrounds, some people from neuroscience background, some people from arts background, liberal arts background, or from a game theory background. All of these kinds of people, when they come together in an environment, in a culturally rich environment, I think we can solve better problems. Now, let's talk about culture, because as we all know, strategy eats culture eats strategy for breakfast every day. So what is the kind of culture do we need in an analytics and AI organization? The first idea is idea meritocracy. You've seen Bridgewater, one of the largest hedge funds in the world. They have this dot collector system by which every meeting, everybody rates everybody else's participation and everybody else's believability on that dimension, on the topic that was discussed. And using that believability scores, they're able to improve the quality of decisions they're making. Here, they've created an open and transparent culture where the best idea wins, not the one with the senior most voice. And that's the kind of cultural thing that if we can build within AI teams, I think we can achieve more success. The other thing is about positive error culture. Gerd Gegerenzer, who's going to speak tomorrow, is going to talk about cultures where error is celebrated and error is good and error leads to learning, as opposed to where error is not good. And finally, how do you create a trust? How do you create trust and autonomy in the team? The last point, really, what I want to come to is governance. You've seen that the rise of ML ops in the last couple of years, and really creating this production automation, where everything can work in a non-human intervention environment, including ML ops. So that's another way in which you can increase the organizational effectiveness of AI. And the last point I want to mention here is responsible AI. Yes, Google has had its share of troubles in around this topic, but Google has also been leading the charge in creating an AI ethics team. If my one recommendation to this client advisory board today is that all of the companies represented in this room are big enough, are already very big, and they need an AI ethics team. You already use AI enough to have an AI ethics committee inside your organization. So to summarize, it's about to accelerate AI within your organization, use these formulas and build a great culture that delivers great AI results to your organization. Thank you.